So for calculating the activation energy, we have on the previous videos watched how we can do it using graphs. And that's the first method. So method number 2 is with using equations. And for using the equations, we need to know the value for rate constant and 2 different temperatures. So actually in the previous one, we used a Excel document and we knew the rate constant and at least 2 temperatures. So we could have used this method as well to calculate the activation energy. So how do we actually do it? We set up the equation, the Arrhenius equation for 2 different temperatures. So we have temperature 1, so we need to apply K1 and temperature 1. For temperature 2, we have the rate constant 2 and temperature 2. What we can see is that we actually, the frequency factor is not dependent on the temperature, so that is just the same. So we want to have A alone on one side, so we move this part over to the other side. So we have ln A equalizes ln K1, and we have a minus in front, we move it to the other side, we switch sign, so that becomes a plus. Activation energy, gas constant, and temperature 1. It's exactly the same for this reaction, just with number 2 instead of number 1. We can write that equation too. So we have ln A equals ln K2 plus activation energy, rate constant, gas constant, and temperature 2. What we can see is that these 2 are actually the same. So if these 2 are the same, this is the same, and this is the same, that means that these right here have to be the same as these right here. So we actually set them equal each other. So I have ln K1, supposed to be a small capital letter, a small letter, plus, so we have ln K1 plus activation energy, temperature 1, and we set equal to this part right here, because these 2 are the same. So ln K2 plus activation energy, gas constant, temperature 2. And then we want to have ln K on the same side. So we move this right here to that side, and we move this part right here to the other side. And what we got if we do it, so this will be minus, we need to switch sign. And minus because we are moving side, and switch sign. So this is now our equation. We apply the logarithmic rules, which saying that ln of something minus ln of another thing will be ln first one divided by the second one. This is equal to, so we see that in common we have activation energy and gas constant. So we put them outside a parenthesis, and we are left with 1 over T1, T2 minus 1 over T1. So now we have an equation here. And remember that the known values, so the known values, we know K, so we can easily calculate this part. This is known. We know the temperatures, so this is known. And we know the gas constant, which is always constant. And then we can calculate the activation energy. That's the only one which is not known for this equation. So we put in these values and we get one value here, put in that value, put in these ones and we get one value here. We divide by this value, multiply by this value, and activation energy is left alone on this side. So in OneNote, I have put out some tasks. You need to apply this equation, either if you start from these two, or if you just use this equation and you calculate the activation energy. Next, you should calculate the frequency factor. So if you know the activation energy, you can put in this equation and you can find the frequency factor. And next, you need to calculate the rate constant for a temperature number 3. And then you know the activation energy, the temperature is given, you then know the frequency factor, so you can just plug in this equation. And remember that if you find a value for LNA, so let's say that you have LNA, we can actually use this example up here. So what we have here is this value. We have the value B, which we know is LNA. This is for method number 1. And B is equal to 14.8. So what we need to do is that, because we want to find only A, not L and A. So we need to take E in the power of L and A. And we need to take E on both sides. So E 14.8. So these ones cancel out and we are left with A are equal to E in the power of 14.8. So every time you find a value or Ln to the value you want to find, you can just take that value or E in the power of that value. Good luck with the tasks on OneNote.